All right, so let's go ahead and talk about these maybe strange-looking formulas. And in particular, right now, we're talking about the binomial distribution. So let's go ahead and talk about these using an example. So suppose a family has, let's say, 10 kids. Family has 10 kids. Okay, and so what we want to decide is something about the probability of maybe observing a certain number of boys or a certain number of girls. Okay, and we're going to assume that the probability of having a boy and a girl is the same. So it's half for either option. Okay, so suppose a family has 10 kids. Starting with this exact type probability, let us start with find the probability that the family has exactly, let's say, 4 girls, okay, out of 10 kids. All right, so this is a binomial type problem because you either are a boy or a girl, so there's 2 choices there. And then we have a set number of trials, right? 10 kids. All right, so to figure this out, this J that you're seeing in this formula is actually, it's just 4, right? So if I want to find the probability, I like to write PR instead of P. They're the same thing. PR just means probability. It's the probability that X equals 4. And X is the number of girls that we're having. All right, so if I wanted to find this probability, I could use Excel. If I pull out Excel, I would just type in, so let me go ahead and write out what it is I'm finding here. Probability X equals 4. And let me go over to another cell, and I would type in equals binom. If I scroll down, you see that dot dist. That's what I want. The number of successes, or num underscore s. The number of successes is 4. The number of trials is 10 kids. Probability of success is 0.5. Or 0.5, since you're either a boy or a girl, you have half probability. And then for cumulative, whenever you're trying to find an exact probability, you're going to use false for cumulative. Okay, press enter, and then we get our answer. Looks like it's 0.21, if I were to round that, right? And let's see, if I were to take that, and then actually, a lot of times we write that as a percentage. And then I can have more decimals if I want it by pressing these buttons over here. So I'll write 20.5. 20.5%. Okay. Or you could have left it as a decimal. Either way, it doesn't matter. All right. So that's an exact type probability. Okay. Going on to the second type probability, we have a fewer than. So next, let me do another question. Find the probability that the family has fewer than or less than, you could say either way, fewer than, let's say, 3 girls. Fewer than 3 girls. Okay? So sometimes, you know, I think it's really helpful to write out all of your options here. So like this family, it could have 0 girls. It could have 1 girl, 2 girls, 3 girls, 4, 5, 6, 7, 8, 9, or it could have 10 girls, right? All kids could be girls. So these are our options for the number of girls, right? It helps to write that out. Then now when I'm thinking about fewer than 3 girls, let's think about what that means. So is 2 girls fewer than 3? Yeah. Is 3 girls fewer than 3? No, right? 3 girls is not fewer than 3. Okay. Between 2 and 3, that's where fewer than is, right? So fewer than means 2 or less. Fewer than means 2 or less. Okay, and remember that the cumulative probability distribution functions, so when I write cumulative equals true in Excel, it needs to know less than or equal to, okay? So I'm less than or equal to 2, not less than or equal to 3, because equal to 3 would not be fewer than 3 girls, okay? So this is what I just figured out. The probability that x is less than 3 is the same thing as the probability that x is less than or equal to 2. Okay? And this less than or equal to 2, this is what I can calculate in Excel. I can't calculate less than 3 directly in Excel. I have to do less than or equal to 2 because that is a cumulative probability distribution function. Okay, so let's go to Excel and let's type in probability that x is less than 3, okay, equals binom.dist, and we're going to write 2, not 3, but 2. Then 10.5 is probability of success, and we're writing true because we're doing less than or equal to 2. Press enter, and there we go. Okay, and I can save that as a percentage by typing this little percent guy, maybe some more decimals. So 5.5%. I'll keep that. So my answer here is 5.5%. So it's pretty unlikely that a family of 10 kids is going to have fewer than 3 girls, which makes sense, right? You have 10 kids and each kid has an equal chance of being a boy or a girl. Having 0 girls, 1 girl, or 2 girls is pretty unlikely. It's more likely that you'll have some more girls, right? Okay, so if we notice, look at this formula, this J here was 3, and J minus 1 is 2, and so that's how we see this formula being used. Less than, let me use different colors, so we have less than 3 equals less than or equal to 2, right? So you see that same formula being used here. Okay. Next one, we have x is greater than or equal to j. Or it's the same thing as 1 minus the probability x is less than or equal to j minus 1, which is the at least probability. Okay, so let's do an example using at least. Let me scroll down. So let's find the probability that this family with 10 kids has at least, let's say at least, let's do 6 girls. Okay, so they have at least 6 girls. Right, and if I use this formula, okay, so at least is greater than or equal to 6, which is the same thing as 1 minus x. So if this is 6, 1 minus x being less than or equal to 5, right? In that formula, I could write that down. X is greater than or equal to 6 equals 1 minus the probability that x is less than or equal to 5. Okay, and that's what that formula tells me, right? But what does that formula mean, right? How did they arrive at that formula? Okay, let's think it through. We don't need to memorize these formulas, all right? So we can have 0 girls, 1 girl, 2 girl, right? A family with 10 kids can have anywhere between 0 and 10 girls. Okay, so what does at least 6 mean? What does that mean? Right? So, is 6 at least 6? If you want at least 6 girls and then you end up having 6 girls, are you happy? Yeah. What about 5? If you have 5 girls and you wanted at least 6, will you be happy? No, right? 5 is not at least 6. Okay. What about 7? Is 7 at least 6? Yeah, 7 is at least 6, right? If you had 7 girls and you wanted at least 6 girls, you'd be happy with a family with 7 girls, right? So at least 6 means 6 or more, okay? We just kind of think that through. We just kind of think it through. What does this mean in English, right? What does at least 6 mean? Okay. All right. So now, okay, I'm convinced, yeah. What I want to figure out is the probability that x is greater than or equal to 6. right? But Excel doesn't like that, right? It will give you a cumulative probability distribution, which is always going to be less than or equal to, okay? So remember, Excel always gives you less than or equal to when you type in that cumulative equals true, okay? Always less than or equal to. So what's less than or equal to? This is less than or equal to down here, okay? This is my less than or equal to area. So the probability that x is less than or equal to 5. Now, I don't want to know the probability x is less than or equal to 5. I want to know it's more than 6 or more. Okay? Well, now I need to use that rule of total probability. So this total probability, the probability that the family has 0 girls or 1 girl or 2 girls or 3 girls, etc., the total probability equals 1. Okay? So if the total probability is 1, I'm interested in knowing this red probability, this area over here. What I can do is I can take 1 and I can subtract off this green probability. Right? So I take 1, I subtract off that green probability, and I'll be left with the red probability. All right, and now if you understand that, then you're good to go. All right, so let's go into Excel. And right now, I'm trying to figure out the probability that x is greater than or equal to 6. All right, let me move my cursor. So I'm going to type in equals 1 minus binom.dist, and I'm going to use 5, right? Less than or equal to 5. 10 trials, 0.5. for the number of probability of success, and then true for cumulative. So that's less than or equal to 5. When you see that true, that means less than or equal to. Less than or equal to what? Whatever number you entered in first, the number of successes. Press enter. I can format that as a percentage. You can leave it as a decimal, but it's easier to interpret when it's a percentage. So 37.7. So my answer here is 37.7%. So I have pretty good chance of having at least 6 girls, right? Pretty good chance of having at least 6 girls. All right, let's do this last one here, more than. Okay, so actually let me keep it 6. So instead of saying at least 6 girls, for this last one, this is the 4th one. 1, 2, 3, 4. Yep. Let's say find the probability that the family has more than 6 girls. Okay, so more than 6 girls. So again, I think it's super helpful to write this out. So the family could have 0 girls. They could have 1, 2, 3. Okay. All right, then let's think it through, right? Now, I mean, we could have just gone straight and used this formula. So more than 6 means 1 minus probability x is less than or equal to 6, right? So if I were to write that down, like just the formula tells me x is more than 6 is 1 minus the probability x is less than or equal to 6. Okay. Let's scroll over a little bit. All right. But if we use this formula, I mean, we didn't actually learn anything. So let's think this through. What's going on here? We don't need that formula with J, right? We can think this through. What does more than 6 mean? Okay. So if we wanted more than 6 girls and we ended up only getting 6 girls, okay, let's just think that through. Is that more than 6? Is 6 more than 6? No, right? 6 is 6. If you wanted more than 6 and you only got 6, you're not happy, right? So what about 7? Is 7 more than 6? If you had 7 girls in your family? Yeah, you'd be happy. You say, I wanted more than 6 girls and I got 7. Yeah, I'm pretty happy about that, right? Same thing with 8, 9, or 10 girls in your family. You'd be happy. So more than 6 is 7 or more, right? So the probability that x is more than 6, right? I could also write this. This is the probability that x is greater than or equal to 7, right? More than 6 is the same thing as greater than or equal to 7. Right, and again, I have this problem where this is in the wrong direction, right? Remember, Excel, it's going to tell me the less than or equal to probability. Excel wants to tell me less than or equal to. Whenever cumulative is true, so whenever cumulative equals true, it wants to tell you the less than or equal to probability. So this is the less than side, okay? The probability that x is less than or equal to 6. If I want to know this green box over here, right, I need to consider that the total probability is 1. The total probability is 1. So 1 minus this yellow box over here, right, less than or equal to 6. If I subtract off this yellow box, then I'll be left with the green box. Right? So the probability that x is more than 6 equals 1 minus the probability that x is less than or equal to 6. Okay, so let's go to Excel and let's type that in. The probability that x is more than 6. Okay, my cursor equals binom.dist. The number of successes, okay, so we want to use 6. The number of trials is 10. 0.5, and true for cumulative. So remember, true for cumulative means that you are doing the less than or equal to whatever number is here. So less than or equal to 6. Okay, so that's what this 6 is coming from here, and true for cumulative always is less than or equal to. Okay. All right, I forgot the 1 minus. Okay, so that will get me the greater than 6 probability. Okay, press enter. Delete that. Make that into a percentage so that it's easy to interpret. Percentage, maybe I'll include some more decimals. All right, so 17.2 equals 17.2%. Right? So the probability that the family has more than 6 girls is 17.2%. Right? And if we think about this, the probability that the family has 6 or more is 37.7%. It makes sense, right? Because here 6 was included, right? So this 37.6 was 6 or more. 37.7, sorry, percent. But then when you don't include 6 and you want 7 or more, then it goes down to 17.2%, which makes sense.